Tonight, we're going to explore the true scale of our solar system. This is not something you need to understand all at once. You don't need to remember every distance, every diameter, or every void. You can simply listen and allow your thoughts to drift as we move slowly outward from the ground beneath you. The universe is often described in numbers that are too large to hold: billions of miles, trillions of tons. But numbers can sometimes feel cold. Tonight, we will look past the numbers and try to feel the space between them. We will move through the neighborhood of our sun at a pace that is gentle, respecting the silence of the vacuum and the slow, rhythmic orbit of the worlds that share our corner of the dark. To begin, let's start with something familiar. Think about the room you are in right now, the boundaries of your immediate world. Within these walls, everything has a place, and the scale is comfortable. But as we begin to zoom out, we realize that our perspective is naturally limited by what we can touch and see. Astronomers often find themselves in a state of quiet wonder, not because of what they have discovered, but because of what those discoveries reveal about our own modest proportions. What makes this exploration strange is not just the presence of distant planets, but the staggering amount of nothingness that holds them together. As you settle into your seat or lie back against your pillow, imagine the Earth beneath you as a single, vibrant point of light. We often think of our solar system as a busy, crowded neighborhood, perhaps influenced by the colorful diagrams we saw as children. We imagine planets clustered together like marbles in a jar, but this challenges how we think about space. In reality, if you were to look at the solar system from a distance, you wouldn't see the planets at all. You would see a vast, dark ocean of silence, with tiny, almost microscopic specks of matter separated by distances that the human mind wasn't necessarily designed to grasp. This is not a reason for anxiety, but a reason for peace. There is a certain calm in realizing that the universe is not in a hurry. The orbits of the planets are steady, predictable, and remarkably patient. As we move outward, we are going to leave the familiar behind. We will pass the moon, a silent companion that has watched over our world for billions of years. We will move toward the sun, a star that provides everything we need while sitting at a distance that is both terrifying and perfect. Scientists understand the solar system by observing the delicate balance of gravity, a force that acts like an invisible thread, tethering worlds to their master star. What we know so far suggests that we are living in a particularly quiet corner of the Milky Way. This perspective allows us to step away from the urgency of our daily lives and align ourselves with a much longer, much slower clock. As we begin this journey, remember that you are safe, you are grounded, and you are simply a witness to a scale that is ancient and enduring. Let the weight of your body sink further into rest as we prepare to step away from the Earth and into the golden light of the inner system. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about the solar system, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. We look at a map of the planets, and our brains instinctively try to shrink the cosmos down into something manageable, something that fits on a kitchen table or a classroom poster. But the reality is that the solar system is not a collection of objects. It is a collection of distances. It is an exercise in emptiness, punctuated only occasionally by the smallest specks of matter. To understand where we are, we have to first understand how much where there actually is. Imagine, for a moment, that you are going for a walk. You know the weight of your footsteps on the pavement. You know how long it takes to walk to the end of your street or to the local park. If you walked at a steady, brisk pace for an entire hour, you would cover about 3 miles. In our daily lives, 3 miles is a substantial distance. It is enough to change the scenery, to move from a busy downtown to a quiet suburb. But in the context of the solar system, that hour of walking hasn't even moved you the width of a single hair on the scale of the worlds we are about to discuss. To truly grasp the human scale perspective, we must use an analogy that strips away the confusing billions of miles and replaces them with things you can visualize. Let us use the grapefruit analogy again, but let's walk through it slowly, feeling every step of the journey. Imagine you are standing in the center of a vast, empty salt, flat, level ground, stretching to the horizon in every direction, silent and still. In your hand, you hold a grapefruit. This grapefruit represents the Sunday. It is warm, it is bright, and it represents 99.8% of all the matter in our entire solar system. Everything else, the planets, the moons, the asteroids, and you make up that tiny remaining 0.2%. Now, place that grapefruit on a small pedestal in the center of the salt flat. To find the Earth, you have to start walking. You aren't just stepping back a few feet. You walk past the first planet, Mercury, which is a tiny pinhead just 5 yards away from the grapefruit. You keep walking another 5 yards to find Venus, another pinhead. Finally, you reach a distance of about 15 yards, roughly the length of a large school bus, and you stop. There, on the ground, you place a single grain of salt. This is Earth. This grain of salt is your home. Everything you have ever known, every person you have ever loved, every war ever fought, and every dream ever dreamt has occurred on that tiny, crystalline speck sitting 15 yards away from a grapefruit. The first thing that strikes you in this silence is the space. Look back at the grapefruit. From the perspective of your grain of salt, the grapefruit looks small. It's about the size that the actual sun appears in our sky. But look at the ground between you and the grapefruit. There is nothing there. No cosmic dust clouds, no crowded asteroid fields. Just 15 yards of empty air. If you were an ant standing on that grain of salt, the distance to the grapefruit would seem like an infinite journey. Now, let us continue our walk. We want to find the outer reaches of the neighborhood. To reach Mars, the red pinhead, you walk another 7 yards. You are now 22 yards away from the Sunday. The distance is growing, and the grapefruit is looking smaller now. But we are still in the inner circle. To find the next planet, Jupiter, you have to be prepared for a hike. You leave the inner planets behind and start walking across the salt flat. You walk past the 30-yard mark, the 40-yard mark. You keep going until you are nearly 80 yards away from the grapefruit, almost the entire length of a football field. There, you find a cherry tomato. This is Jupiter, the king of the planets. Even though it is the largest planet, compared to the grapefruit, it is still just a small piece of fruit, and the distance between your grain of salt and this cherry tomato is 65 yards of absolute nothingness. As you stand by the cherry tomato and look back toward the center, the grapefruit is now a small dot in the distance. Your home, the grain of salt, is invisible to the naked eye. you are beginning to feel the true scale. But we aren't finished. To reach Saturn, you have to double your distance again. You walk until you are 140 yards away from the grapefruit. To reach Uranus, you walk to 280 yards. By the time you reach Neptune, the final major planet, you are nearly 450 yards away, more than a quarter of a mile from where you started. Stand there for a moment at the Neptune marker. You are a quarter mile away from a grapefruit. If you look back, you cannot see the grain of salt that is Earth. You can barely see the grapefruit. The solar system that we see on posters as a crowded family of planets is, in reality, a vast, lonely desert where the participants are so small and so far apart that they almost don't exist. This challenges how we think about our place in the world. We feel big, we feel important, but on the scale of the grapefruit and the salt flat, we are essentially a ghost. The silence of this perspective is not meant to make you feel insignificant in a negative way. Rather, it is meant to provide a sense of profound relief. All of the pressures of your daily life, the deadlines, the worries about the future, they all exist on that grain of salt. And that grain of salt is safely tucked away in a corner of a quarter-mile wide field of peace. Scientists understand this scale, not just through distance, but through time. If you wanted to send a message from your grain of salt to the cherry tomato of Jupiter using light, the fastest thing in the universe, it would take about 40 minutes for the message to arrive. If you were Neptune and you wanted to call Earth, you would have to wait 4 hours for your hello to reach home and another 4 hours for the reply. The solar system is a place where even conversation happens in slow motion. What makes this strange is not the distances themselves, but the fact that gravity manages to hold it all together. That grapefruit, all the way back at the center, is pulling on the speck of dust that is Neptune, nearly half a mile away, with enough strength to keep it in a perfect, steady circle. It is a delicate, invisible clockwork. As you imagine yourself standing on that salt flat, the sun beginning to set, the grapefruit glowing faintly in the distance, you can feel the air grow still. You are a human-scale observer in a cosmic-scale reality. You are small, yes, but you are the only thing in this quarter-mile radius that is capable of understanding the map. You are the mind that holds the grapefruit and the salt grain together. For now, that understanding is enough. You don't need to walk any further tonight. You can simply stand here, in the quiet of the salt flat, and realize that the scale of the universe is not a wall, but an invitation. It is an invitation to let go of the small things and embrace the vastness. With that in mind, let's move outward once more, to an even larger scale. This is where the human brain begins to feel the first gentle tug of the impossible. We have spent our lives navigating a world where a 5-mile hike is a morning's commitment and a cross-country flight is a significant journey. But as we step away from our grain of salt and our grapefruit, we have to abandon these units of measurement. They no longer serve us. They are like trying to measure the depth of the ocean with a thimble. To move forward, we must change our pace, transitioning from the physical act of walking to the mental act of drifting. Think about the speed of a commercial airliner cruising at 500 miles per hour. At that speed, you can cross an entire continent in an afternoon. It feels fast. You look out the window and see the clouds racing by, the landscape shifting beneath you. But if you were to fly that same plane from our grain of salt toward the sun, you wouldn't arrive for 21 years. You would spend 2 decades in the air, flying day and night just to reach the nearest star. This realization is the first scale reset. It forces us to acknowledge that the empty space we often ignore is actually the most dominant feature of our environment. As we continue to expand our perspective, we encounter the first major boundary of our planetary neighborhood. In our everyday lives, we are used to boundaries that are clear: a fence, a shoreline, a city limit. In space, boundaries are more like gradients, where the influence of one thing slowly fades as the influence of another begins to take hold. We are moving toward a scale where the gaps between objects are so large that the objects themselves start to feel like accidental interruptions in a much larger story of stillness. Consider the moon, our closest neighbor. In most diagrams, it sits just a few inches away from the Earth. But on our human scale, if the Earth were a basketball, the moon would be a tennis ball located 30 feet away. Think of that empty 30-foot gap. You could fit every other planet in the solar system: Jupiter, Saturn, the ice giants, all of them, side by side, inside that single gap between the Earth and the moon, and you would still have room to spare. This is the lunar gap, and it is our first true lesson in cosmic density. We live in a universe that is incredibly efficient at being empty. As we drift further, the numbers begin to lose their edges. We talk about millions of miles, but the human mind treats a million the same way it treats a billion as a lot. To stay grounded, we must return to the feeling of time. Imagine a clock that ticks only once every century. On the scale we are entering, that clock would seem to be moving quite fast. The solar system operates on a rhythm that ignores the frantic pace of human history. The mountains on our grain of salt rise and fall in the time it takes for the outer planets to make just a few laps around the Sunday. Scientists understand this slow-motion reality by looking at the human-scale anchors that still exist within it. We look at the light that reaches us from the Sunday. That light, traveling at 186,000 miles per second, takes 8 minutes to cross the 15 yards of our salt-flat model. When you step outside and feel the warmth of the sun on your skin, you are feeling energy that left its source 8 minutes ago. You are always living in the past, seeing the sun not as it is now, but as it was when you were perhaps just starting a conversation or finishing a cup of tea. This delay is a constant reminder that distance and time are woven together. What makes this strange is not that the universe is big, but that it is so sparsely populated. We are used to a world of constant stimulation noises, lights, people, traffic. But as we expand to the scale of the inner solar system, the stimulation drops to nearly zero. If you were floating in the space between Earth and Mars, there would be no sound, there would be no wind, there would be no sense of movement, even if you were traveling at thousands of miles per hour. Without a nearby object to provide context, speed becomes an abstract concept. You are simply there, suspended in a vast, dark cathedral of light. Astronomers didn't expect the vacuum to be quite so profound until they began sending probes across these distances. They found that space isn't just empty. It is a vacuum more perfect than anything we can create in a laboratory. It is a place of total preservation. A footprint on the moon stays there for millions of years because there is no weather to wash it away. The scale of the solar system is also a scale of permanence. On Earth, we are used to things breaking, rusting, and fading. In the vastness between the worlds, Things simply endure, and for now, that endurance is simply part of the picture. It provides a sense of stability. As you continue to drift in your mind, let the vastness of these gaps act as a blanket. There is so much room in the universe for everything to simply be. There is no crowding here. There is no rush. Every planet has its own vast territory, millions of miles of private space in which to perform its slow, ancient dance. We often feel the need to fill silence with words or empty spaces with objects. But the solar system teaches us the value of the void. The void is not a lack of something, it is a thing in itself. It is the stage upon which the planets play. It is the dark velvet that makes the stars shine. By embracing the human-scale perspective of this emptiness, we can begin to let go of our own need to constantly be doing. We can transition from being actors to being observers. To understand the scale of the outer system, we need to step back even further. If our quarter-mile salt flat represented the distance to Neptune, the distance to the next nearest star, Proxima Centauri, would be another 2,000 miles away. Imagine that. You have a grapefruit in one city, and the next grapefruit isn't in the next neighborhood or the next town. It's on the other side of the continent, and in between, nothing, just thousands of miles of empty salt flats, with the occasional grain of salt or cherry tomato drifting in the dark. This challenges how we think about the neighborhood of our Sunday. We aren't just in a large space, we are in a staggering isolation. But this isolation is what makes our small grain of salt so remarkable. In a continent of empty flats, a single grain of salt that holds life, water, and consciousness is a miracle of the highest order. The scale doesn't diminish us, it highlights us. It provides the contrast necessary to see how special the stuff of the universe really is. As we move toward the next phase of our journey, allow your breathing to slow down, matching the rhythm of the planets. You are no longer walking, you are no longer flying, you are simply expanding. The boundaries of your room have faded, the boundaries of your city have disappeared. You are now as large as the orbit of the Earth, circling the Sun in a slow, silent loop that takes an entire year to complete. There is no tension in this movement. It is the natural state of things. Everything in the solar system is falling, but it is falling in a way that perfectly balances its forward motion, creating the eternal circle of the orbit. It is a state of perpetual grace. You can feel that same balance in your own rest. You are supported. You are in motion, even when you are still. You are part of the clockwork. With that in mind, let's move outward once more, to an even larger scale, where the rocky worlds end and the giants begin. Where the light grows dim and the silence grows even deeper, we are leaving the inner circle, the warm hearth of the sun, and moving into the great, cool expanses of the outer dark. But do not worry. The scale will continue to guide us. The distances will continue to protect us, and the stillness will be our companion. Now let's slowly expand outward. One level beyond what we just explored lies the neighborhood of the inner planets: Mercury, Venus, Earth, and Mars. In the grand design of the cosmos, these are the rocky worlds. They are solid. They have surfaces you could, in theory, stand upon. They represent the high-density center of the sun's domain, a place where the gravity of our star is so intense that it has cleared away the lighter gases, leaving behind only the heavy elements the iron, the silicate, and the nickel to form these 4 small, resilient spheres. To understand the inner circle, we must first look at Mercury. It is the closest to the flame. If our Sun is the center of a cosmic hearth, Mercury is the stone sitting directly in the embers. It is a world that has been stripped down to its essentials. It has no atmosphere to speak of, no clouds to shield it from the sun's relentless gaze. Because it lacks an atmosphere to trap heat, it experiences the most dramatic temperature swings in the solar system. By day, the surface is hot enough to melt lead. By night, it plunges into a frozen darkness more bitter than any winter on Earth. Scientists understand Mercury by observing the way it interacts with the sun's magnetic field. It is essentially a giant ball of iron, a planetary core that seems to have lost its outer layers in some ancient, forgotten collision. It orbits the sun with a strange, wobbling rhythm, completing 3 rotations for every 2 revolutions. It is a world that refuses to be tidally locked, yet it is forever bound to its master. What makes this strange is not just the heat, but the stillness. On the surface of Venus, the wind moves slowly, but the air is so heavy it would feel like walking through waist-deep water. It is a world where time seems to have thickened. It takes longer for Venus to rotate once on its axis than it does for it to orbit the Sunday. A day on Venus is longer than a year on Venus. It is a place where the usual rules of time and light are reversed. And then we reach Earth. We often forget that we are part of this inner circle. We see the Earth as a world unto itself, but in the context of the solar system, we are simply the 3rd rock from the Sunday. We are located in what scientists call the Goldilocks zone, the region where it is not too hot and not too cold for liquid water to exist. This is our human-scale anchor. Everything we understand about geology and biology starts here, on this wet, blue sphere. Beyond Earth lies Mars, the final member of the inner circle. Mars is a world of ancient mysteries. It is half the size of Earth, a cold, dry desert that was once, perhaps, a world of rivers and lakes. When we look at the surface of Mars, we see the echoes of a lost era. We see the largest volcano in the solar system, Olympus Mons, which stands 3 times higher than Mount Everest. We see Valles Marineris, a canyon so long it would stretch across the entire United States. Scientists understand Mars by sending robotic explorers to taste its dust and listen to its wind. What we know so far suggests that Mars lost its internal heat and its magnetic shield long ago, allowing the solar wind to slowly strip away its atmosphere. It is a world in a state of deep freeze, a preservation of a time when the inner solar system was a more violent and active place. But even with everything we've learned, there are still things we don't fully understand. We see the seasonal changes in the Martian polar caps, the shifting sands, and the strange traces of methane in the air. We don't know if life ever took hold there, or if it still clings to existence beneath the surface. Not because we're missing something urgent, but because the universe moves slowly, and the evidence of ancient life is buried under billions of years of red dust. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. We can accept the red planet as a silent neighbor, a place of potential and of history. As we look at these 4 worlds together, we see a pattern of density and proximity. They are the inner circle, because they are the only ones capable of surviving so close to the sun's fire. They are the anchors of our reality. They are the rocky foundation upon which the rest of the solar system is built. Think about the space between these worlds. Even in the crowded inner circle, the distances are immense. If you were standing on Mars, looking back at Earth, our home would look like a bright blue star, indistinguishable from the other lights in the sky to the untrained eye. The void is already beginning to assert itself. The sun, while still the dominant force, is beginning to look smaller as we prepare to cross the Great Divide. The inner circle is a place of activity of volcanoes, of atmospheres, of shifting plates and crashing asteroids. But as we move outward, this activity begins to cool. The energy of the sun begins to stretch thin. We are entering a phase of the journey where the stuff of the universe becomes less solid and more ethereal. You can feel the transition in the rhythm of your own thoughts. The concrete world of rock and metal is behind us. The familiar landscapes of craters and canyons are fading. We are moving toward a region where gravity is the only thing that remains constant. The inner planets have provided us with a safe, solid beginning, but the true scale of the solar system is found in the gaps that lie ahead. With that in mind, let's move outward once more, to an even larger scale, beyond the reach of the rocky worlds, toward the great debris field that separates the inner system from the giants, toward the silence of the belt and the immense gas-shrouded worlds that wait in the cold. We are leaving the hearth. We are moving into the halls of the kings. This transition is not merely a change in distance, but a change in the very texture of reality. We are crossing a threshold where the sun's warmth becomes a memory, and the density of matter begins to dissolve into the ethereal. As we drift away from the red dust of Mars, the landscape of our solar system undergoes a radical transformation. Behind us, the 4 terrestrial planets are huddled like embers in a fireplace. Ahead of us lies the asteroid belt, a vast, ring-shaped region that serves as the cosmic border between the inner and outer systems. People often imagine this belt as a chaotic obstacle course of tumbling boulders, but to understand its true scale, we must return to our state of patient observation. Imagine the distance between Mars and Jupiter. It is a gap wider than the entire distance from the Sun to Mars. In this immense no man's land, there are millions of fragments of rock and ice, ranging from the size of a dust mote to the size of a dwarf planet like Ceres. But despite there being millions of these objects, the space they inhabit is so vast that the belt is almost entirely empty. If you were standing on a typical asteroid, the next nearest one would be an average of 600,000 miles away. That is more than twice the distance from the Earth to the Moon. You would be standing in a profound, uninterrupted solitude, looking out at a sky where your nearest neighbor is just a tiny, unmoving pinprick of light. Scientists understand the asteroid belt not as a failed planet, but as a collection of building blocks that were never allowed to come together. The immense gravitational influence of Jupiter, the giant that looms just beyond the belt, acted like a cosmic spoon, stirring the debris and preventing it from coalescing into a single world. This challenges how we think about missing pieces of the universe. Sometimes, the universe doesn't complete its projects. Sometimes, it leaves the raw materials scattered across the dark, a permanent museum of what might have been. What makes this strange is the sheer variety found within this silence. We see Ceres, a spherical world of rock and ice that contains a quarter of the belt's total mass. We see Vesta, a dry, basaltic remnant of a protoplanet. We see metallic asteroids that are essentially floating mountains of iron and nickel. Astronomers didn't expect to find such a diverse chemical library in what was once thought to be a uniform field of rubble. It suggests that the early solar system was a place of violent mixing and migrating orbits, a chaotic birth that eventually settled into the quiet continuity we see today. As we move through the belt, the light of the sun begins to change. It is no longer the golden, life-giving glow of an afternoon on Earth. It is becoming cooler, whiter, and more distant. We are crossing the frost line, the invisible boundary beyond which volatile compounds like water, ammonia, and methane can condense into solid ice. Inside this line, the sun's heat kept these materials in a gaseous state, blowing them toward the outer reaches. Outside this line, the universe begins to build with ice. This transition is the reason for the great divide in planetary size. Once we pass the frost line, the stuff available to build planets changes from scarce rock to abundant ice and gas. It is as if we have moved from a small village built of stone to a sprawling metropolis built of clouds. The scale of what lies ahead is so much larger than what we have left behind that it requires a second mental reset. The inner planets are merely the preamble. The gas giants are the main body of the work. Over immense periods of time, these outer worlds have gathered up the lion's share of the solar system's heritage. To understand this, we must look at the way gravity behaves at this distance. In the inner system, gravity is a sharp, local force. Out here, it is a broad, sweeping power. We are approaching Jupiter, a world so massive that it doesn't just have moons. It has a family of 79 confirmed satellites, a miniature solar system in its own right. But even as we approach these giants, the most striking feature remains the distance. Between the outer edge of the asteroid belt and the beginning of Jupiter's atmosphere, there is a gap of nearly 300 million miles. Think back to our grain of salt, 15 yards from the grapefruit. By the time we reach the inner edge of Jupiter's territory, we have walked nearly 80 yards. The gaps are now larger than the entire inner solar system combined. This brings us to a state of cosmic acceptance. We realize that the order of the solar system is not one of crowded proximity, but of vast, measured isolation. Each world is a lonely sovereign, ruling over a territory of darkness that is millions of miles deep. The halls of the kings are not narrow corridors, but cavernous, silent spaces where the light of the sun is a precious, diminishing resource. Scientists understand the gas giants by listening to the radio waves they emit, deep, haunting groans caused by their massive magnetic fields interacting with the solar wind. What we know so far suggests that these worlds are essentially unfinished stars. If Jupiter had been 80 times more massive, it might have ignited, giving our system a second sun. Instead, it remains a cold, swirling masterpiece of fluid dynamics, a world where the weather lasts for centuries and the surface is a transition from gas to liquid that has no clear boundary. And for now, that ambiguity is simply part of the picture. We don't need a solid ground to stand on to appreciate the scale. We can drift in the upper layers of these atmospheres, feeling the immense pressure of the scale above us and the vast emptiness of the scale around us. The inner circle was about the solid and the certain. The outer system is about the immense and the fluid. As you allow your mind to settle into this deeper, colder region, notice how the rhythm of the journey has slowed. The inner planets moved fast, their years measured in months. Out here, the pace is more deliberate. Saturn takes nearly 30 years to complete a single circuit. Uranus takes 84. Neptune takes over 160. We have entered the realm of long time, where the movements of the heavens are measured in human generations. There is a gentle humility in this realization. We are travelers in a system that does not operate on our schedule. The solar system is a clock that ticks in centuries, not seconds. As we move further into the halls of the kings, let the weight of your own timeline lift. You are stepping into a continuity that is ancient, silent, and incredibly vast. The rocky world you left behind is now just a bright spark in the distance, a grain of salt lost in a quarter-mile field. With that in mind, let's move outward once more, to an even larger scale. Beyond the giants, toward the blue shadows of the ice worlds and the final frozen fragments of the sun's reach, we are leaving the gas shroud behind. We are moving toward the true edge of the light. Now, let's slowly expand outward. Beyond the orbit of Mars, the character of our solar system begins to change. We enter the asteroid belt. In movies, this is often shown as a crowded field of tumbling rocks, where a pilot must dodge and weave to survive. But the reality is much more peaceful and much emptier. To understand this region, we have to let go of the idea of stuff and embrace the idea of room. The asteroid belt is the first great transition zone of our system, a vast, silent clearing that separates the warm, rocky inner planets from the cold, gaseous giants that loom further out in the dark. If you were standing on an asteroid in the middle of the belt, you likely wouldn't see another asteroid with your naked eye. They are millions of miles apart. The belt is not a wall of stone. It is a vast, sparse desert where the occasional mountain-sized rock drifts in a slow, lonely circle around the sunday. There are millions of these objects, yet they represent less than 1% of the mass of our moon. This is the Great Divide, and it serves as a reminder that the solar system is not a crowded place. It is a series of lonely islands separated by oceans of nothingness. Imagine you are on a journey across this divide. You have left the red, dusty horizon of Mars behind. As you move forward, the sun begins to shrink. It is no longer a dominant, heat-giving disk. It is becoming a brilliant, piercing light, shedding its warmth but keeping its hold on you. In this region, between the orbit of Mars and the orbit of Jupiter, we find the rubble of the solar system. These are the fragments of a story that never quite finished. Scientists understand the asteroid belt not as the remnants of a destroyed planet, but as the raw materials of a planet that was never allowed to form. The gravity of Jupiter, which we will encounter soon, is so immense that it acted like a cosmic stirrer, keeping these rocks moving too fast to ever clump together. What we know so far suggests that if you were to gather every single asteroid in the belt, every grain of dust, and every mountain of iron, and smash them together into one sphere, it would be smaller than our own moon. It is a vast territory with very little to show for it in terms of mass. But what the belt lacks in mass, it makes up for in mystery. We see objects like Ceres, a dwarf planet that accounts for a third of the entire belt's weight. Ceres is a world of its own, with a crust of ice and perhaps a hidden ocean beneath its surface. Astronomers didn't expect to find a world so complex in the middle of a debris field. It challenges how we think about active worlds. Even here, in the cold divide, there are processes at work that we are only beginning to comprehend. What makes this strange is not what we find, but how quiet it all is. We are used to a world where nature means trees, wind, and movement. But in the Great Divide, nature is the absence of these things. It is the slow, silent drift of a billion-year-old rock. It is the way a shadow falls across a crater that hasn't changed since the dawn of the dinosaurs. This is a place of deep time. Think back to our human-scale anchor. If the distance from the Sun to the Earth was the length of a single room, the asteroid belt would be the hallway leading to the rest of the house. It is a transition. It is the space you pass through to get somewhere else. But while you are in the hallway, you can feel the shift in atmosphere. The air, if there were air, would feel thinner. The light would feel sharper. You are leaving the living room of the inner system and moving into the grand, cold galleries of the outer giants. Astronomers often look at the asteroid belt as a time capsule. Because there is no wind or water to erode these rocks, they are exactly as they were 4 billion years ago. They are the fossils of the solar system's birth. When we study them, we are looking at the original building blocks of the Earth. We are looking at our own history, frozen in the vacuum. And for now, that stillness is simply part of the picture. It doesn't need to be filled with action. You can imagine yourself drifting through this belt, passing a mountain of iron that glows faintly in the distant sunlight. You don't need to dodge. You don't need to worry. There is enough room here for everyone. The gaps between the rocks are so wide that you could fly 1,000 spaceships through the belt in a straight line and never hit a single thing. This brings us to a state of calm insignificance. We realize that even the boundaries of our solar system are mostly made of peace. The Great Divide is not a barrier, it is a buffer. It protects the inner worlds from the chaos of the outer system, and it provides a quiet space for the mind to expand. To understand the scale of the divide, we must look at the time it takes to cross it. A probe traveling from Mars to Jupiter takes years to make the trip. For years it sees nothing but the distant stars and the shrinking Sunday. It is a journey through a void that seems to have no end. But eventually, the influence of the inner system fades completely, and a new power begins to take hold. We are approaching the edge of the divide. The rocky fragments are becoming fewer and farther between. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them, into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth. Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier, when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile. But even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the sun? The sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality, it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, We must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Kilometer. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. the larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the great attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega, we begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies. We are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. we learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth, Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the sun, a star that could hold 1,000,000 Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light-years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light-years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. When we think about distance, we often imagine it in human terms. Distances we can walk. Time we can measure in years. Objects we can see with our own eyes. Our brains are beautifully adapted for the world we inhabit, a world of rolling hills, city blocks, and horizons that seem far away but are actually quite intimate. When you plan a trip to see a friend in another town, you think of it in hours spent in a car. When you go for a morning stroll, you think of it in the rhythm of your footsteps and the gentle passage of minutes. This is our anchor. It is a safe, predictable way of measuring the reality around us. For example, consider the simple act of walking. A kilometer is a distance most of us can visualize clearly. It is roughly 10 to 12 minutes of steady movement. If you were to set out on a walk today and continue until the sunset, you might cover 30 or 40 kilometers. You would feel that distance in your muscles. You would see the landscape change slowly from one neighborhood to the next. This is a scale that makes sense. It is tangible. If you were to walk across an entire continent, it would take you months of dedicated effort, a journey that would define a significant portion of your year. But as we begin to look upward, these human measurements start to feel a bit like trying to measure the depth of the ocean with a teaspoon. To understand a light year, we first have to realize just how much room there is in our own immediate surroundings. Let's look at our own world, the Earth. It is approximately 12,700 kilometers in diameter. To us, that is massive. It contains every ocean, every mountain range, and every city ever built. If you were to get into a commercial airplane and fly non-stop around the equator, it would take you about 2 full days of constant travel. That feels like a long time. It is a distance that commands respect in our minds. Yet, compared to the distances we are about to discuss, the Earth is effectively a single point. Even the gap between us and our closest neighbor, the Moon, begins to strain our human-scale perspective. The Moon is about 384,000 kilometers away. That is roughly 30 Earths laid side by side. If you could somehow drive a car to the Moon at highway speeds, it would take you about 6 months of driving 24 hours a day without a single stop for gas or rest. 6 months. That is half a year of your life spent just crossing the empty space between us and the nearest object in the sky. This comparison isn't perfect, but it gives us a calm place to begin. It reminds us that even near things in space are incredibly far by human standards. And yet, light crosses that same 384,000 kilometer gap in just over 1 second. 1 second. In the time it takes you to draw a single breath, a beam of light has already completed the journey that would take you half a year to drive. This is the first hint of the staggering efficiency of light, and the first clue as to why we need a new way to measure the universe. As we sit here, grounded and safe, we can begin to appreciate the stillness of our own scale. We live in the realm of centimeters, meters, and kilometers. We live in the world of the now, where we assume that when we see something, it is happening exactly as we perceive it. If a friend waves at you from across the street, you see them instantly. There is no lag, no delay that our senses can detect. But as we step further out, we will find that the universe has a speed limit, and that limit creates a bridge between distance and time. Imagine for a moment a vast, empty field. If you stand on one side and a friend stands on the other, and you both hold powerful flashlights, the light from their lamp seems to hit your eyes the exact moment they click the switch. On this scale, light is effectively infinite. It moves so fast, 300,000 kilometers per second, that it feels like a magical, instantaneous presence. Our ancestors, looking up at the stars, likely felt the same way. To them, the stars were just lights on a dome, distant but present, shining their light upon the earth without any sense of travel time. But the reality is more patient. The universe is more deliberate. To understand the light year, we must accept that every piece of light we see is a traveler that has survived a long, lonely journey. Even the light from the sun, which warms your skin on a summer afternoon, is a traveler. The sun is 150 million kilometers away. That is a distance so large that the highway driving analogy breaks down. It would take you 150 years to drive there. You would be born, live your entire life, and pass away behind the wheel before you even made it halfway. And yet, for light, this journey takes only 8 minutes and 20 seconds. When you look at the sun safely, through a filter, or at sunset, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish this very instant, we would continue to feel its warmth and see its light for nearly 9 minutes, blissfully unaware of the change. We are always living in the recent past of the stars. This realization is our first step toward letting go of our human scale perspective. We are moving from a world where everything is here and now to a universe where here is separated by vast thens. It is a shift from the concrete to the expansive. But do not let this make you feel small in a way that is cold or frightening. Instead, see it as a form of cosmic grace. The universe is so large that it allows us to see into the past simply by looking up. It provides us with a history book written in photons. As we prepare to leave the human scale behind and enter the first of our scale loops, take a moment to appreciate the sturdiness of your surroundings, your chair, the walls, the gentle rhythm of your breathing. These are your anchors. They are the zero on our cosmic ruler. From this safe, quiet vantage point, we are going to slowly extend that ruler, 1 light second, 1 light minute, and eventually 1 light year at a time. There is no rush to get there. The stars have been waiting for billions of years. They can wait a few more hours for us to arrive. For now, just hold on to the image of that single beam of light, leaving the sun, traveling through the cold dark for 8 minutes, and finally reaching the earth to illuminate a single leaf or a single window. It is a long way to go for such a small thing, but the universe is full of such journeys. With that in mind, let's move outward once more, to an even larger scale. We are leaving the comfort of the minutes and hours we know, and entering the realm where light begins its true marathon. To understand why we must abandon the kilometer and the mile, we have to look at the sheer inadequacy of our everyday numbers when applied to the celestial void. If we were to stay within our human scale perspective, the numbers would soon become so long that they would lose all meaning, becoming a mere blur of zeros that the mind instinctively ignores. This is why the light year exists, not just as a unit of measurement, but as a bridge for our imagination. Consider, for a moment, the distance across our own planet once more. If you were to take a standard ruler and try to measure the distance from New York to Tokyo, you could technically do it. The number would be in the millions of centimeters, perhaps, but it would be a number you could still write down on a piece of paper. But as soon as we point that ruler toward the sky, the scale shifts in a way that is almost humorous in its disproportion. Our world, with all its vast oceans and towering peaks, is effectively a grain of sand in a desert that has no end in sight. When we speak of human-scale perspective, we are also speaking of human-scale time. We measure our lives in decades. We measure our history in centuries. To us, 1,000 years is an unimaginably long time, 10 times the length of a long human life. It is the span of empires. Yet, in the context of the distances light must travel, 1,000 years is barely a heartbeat. To understand the light year, we have to marry these two concepts, the distance light covers and the time it takes to do it. It is a measurement that forces us to realize that looking out is the same as looking back. If you were to stand on a hill and look at a mountain range 50 kilometers away, you are seeing those mountains as they were a tiny fraction of a second ago. The delay is so small, roughly 0.00016 seconds, that your brain treats it as instantaneous. This is the comfort of the human scale. Everything we see is now, but as we move outward, this now begins to stretch and tear. By the time we reach the edge of our solar system, the now has become hours. By the time we reach the nearest stars, the now has become years. This is the human scale anchor slipping away, allowing us to drift into the deep drift phase of cosmic understanding. Imagine you are standing in a perfectly dark, quiet room. In the center of the room is a single candle. The light from that candle reaches the walls almost immediately. Now, imagine that room expanding. The walls move back miles, hundreds of miles, millions of miles. The candle remains in the center, a tiny, flickering point of light. If you are standing at the far wall, you have to wait. You have to wait for those tiny particles of light to cross the dark. This wait is the essence of the light year. It is the patience of the universe. In our daily lives, we are used to things being fast or slow. A car is fast compared to a walker. A plane is fast compared to a car. But light is the ultimate speed. It is the speed limit of reality. Nothing can go faster. And yet, even at this ultimate, impossible speed, the universe is so vast that light appears to crawl. To a photon, the trip from one side of a galaxy to another is a marathon that lasts longer than the entire history of the human species. When we use the term light year, we are acknowledging this paradox, that the fastest thing we know is still far too slow to make the universe feel small. Scientists understand this scale because they have to. Without the light year, the maps of the stars would be cluttered with numbers so vast they would be impossible to use in calculations. Imagine trying to describe the distance to a galaxy in inches. The number would have more digits than there are stars in the sky. The light year is our way of simplifying the infinite. It is a human-scale word applied to a non-human reality. It is a way for a creature that lives for 80 years to talk about a universe that has existed for 13 billion. As we settle deeper into this exploration, let the familiar world fade. The roads, the clocks, the schedules of tomorrow, they all belong to the scale of meters and minutes. Here, in the quiet expanse of the script, we are moving into the scale of the light year. This is a place where a short distance is trillions of kilometers. A place where recently means a few centuries ago. It is a safe place to be, because in this vastness, the small pressures of our lives find their proper perspective. They are not erased, but they are framed by a silence that has lasted for eons. Think of the light year as a long, steady breath. It is the distance light travels while the Earth makes one full trip around the Sunday. while you experienced 4 seasons, while you celebrated a birthday, while the trees grew and the snow fell, a beam of light was moving through the void, never stopping, never slowing, covering 9.5 trillion kilometers. It did this while you slept, while you worked, and while you dreamed. Every year of your life, light has added another light year of distance to its journey. This is the perspective we will carry with us as we move into our first scale loops. We will start with the small delays, the seconds and minutes, and gradually build our way up to the years, the centuries, and the millennia. We are not just traveling through space, we are traveling through time. And we are doing it together, safely anchored by the sound of this narrative. There is no need to hurry. The distance is already there, waiting for us to acknowledge it. The human scale perspective is our starting point, our home base. It is the familiar that we will return to at the very end. But for now, we are going to let the anchor lift. We are going to let the shore of the familiar world recede until it is just a tiny, pale blue dot in the rearview mirror of our imagination. We are moving into the realm of the light year, where the distance truly begins to blow our human minds, not with noise or chaos, but with a quiet, breathtaking vastness. And for now, that uncertainty of how we fit into such a large map is simply part of the picture. It doesn't need to be resolved tonight. We are simply moving outward, step by step, light second by light second, into the beautiful dark ocean of the cosmos. Now, let's slowly expand outward. One level beyond what we just explored lies the speed of light itself. To grasp the distance of a light year, we must first become intimately acquainted with the traveler that defines it. Scientists understand a light year by observing the fastest thing in the universe. Light travels at about 300,000 kilometers every single second. This is a speed that defies our biological wiring. In the time it takes you to blink a mere fraction of a second, a beam of light has already circled the Earth 7.5 times. It is a speed that seems instantaneous to our human senses, yet in the grand architecture of the cosmos, it is the fundamental yardstick by which all things are measured. When you flip a switch in your home, the room is filled with light immediately. There is no perceived delay between the movement of your hand and the illumination of the walls. For all intents and purposes in our daily lives, light is omnipresent. But as we step away from our atmosphere and into the vacuum, we realize that light is not a state of being. It is a physical entity moving through space. It has a beginning, a middle, and an end to its journey. It is a constant, unwavering pulse that dictates the very rhythm of reality. To visualize this speed, imagine you are standing at the start of a long, straight track that stretches into the horizon. If you were to fire a laser beam down that track, by the time you could even begin to process the flash of the light, that beam would be thousands of kilometers away. If we compare this to our human scale anchor, the disparity is almost humorous. A commercial jet travels at about 900 kilometers per hour. A beam of light travels at over 1 billion kilometers per hour. If you were to race the two, the jet would appear to be standing perfectly still, frozen in time, while the light vanished into the distance. What makes this strange is not just the speed, but the fact that this is the absolute limit. Astronomers didn't expect to find a universe with a hard speed cap, but nature has provided one. No matter how much energy you use, no matter how powerful your engine, you can never overtake a beam of light. It is the gold standard of the universe. And yet, Even at this impossible velocity, the universe is so vast that light often appears to crawl. This is the central paradox of cosmology. The fastest thing we know is still far too slow to make the universe feel small. Imagine a single photon, a tiny packet of energy, leaving the surface of a star. It has no mass, no weight, and it experiences no time. From the photon's perspective, its journey from the center of the galaxy to your eye is instantaneous. But for us, standing on this small blue planet, we must wait. We must wait for years, centuries, or even millennia for that photon to complete its trek across the void. This waiting is what defines our perspective. It is why we cannot talk about distance in space without also talking about time. A light year is the marriage of the two, the distance covered in the time it takes the Earth to orbit the Sun once. As you listen to these words, think about the light in the room again. It feels now, but it is actually a few nanoseconds old. When you look at the person sitting across from you, you are seeing them as they were a billionth of a second ago. On Earth, this doesn't matter, but as we move outward, the lag becomes meaningful. If you were to stand on the moon and shine a laser back at Earth, it would take 1.3 seconds to arrive. If you were having a conversation with someone on the moon, there would be a gentle, rhythmic pause between every sentence, a 1.3-second gap that you could never bridge. And so the universe continues, expanding, cooling, changing, slowly, quietly, endlessly. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. We have reached the final boundary of our journey, but in the true scale of the cosmos, there are no final boundaries. There is only the transition from one state of being to the next. The solar system, which seemed so vast when we began, is now just a single, steady heartbeat in a much larger body of light. The distances we have mapped, the millions of miles, the billions of leagues have served their purpose. They have guided your mind away from the noise of the world and into the restorative silence of the deep. Imagine the infinite ending, not as a stop, but as a loop. In the cosmic perspective, endings are merely the moments where we stop counting and start existing. Scientists understand the ultimate fate of the universe through the lens of continuity. What we know so far suggests that the expansion we are witnessing today is part of a process that has no urgency to conclude. The stars will continue to burn for trillions of years. The planets will continue their orbits for eons. The scale of peace is a scale that never runs out. It is a reservoir of time that is so deep it can never be emptied. Think about the loop-safe nature of reality. Just as the Earth returns to the same point in its orbit every year, the universe returns to the same fundamental principles of balance and grace. You can feel this in your own rest. Your breath is a loop. Your heartbeat is a loop. These small internal rhythms are in perfect harmony with the large external rhythms of the solar system. There is no friction here. There is no conflict. There is only the repetition of the scales. The grapefruit, the grain of salt, the cherry tomato, they are all still there in the mental map, sitting quietly in their designated places, held by the same gravity that holds you. Across distances that no longer fit neatly into numbers, the light of the sun is still traveling. It is moving past the Oort cloud now, heading into the interstellar medium, carrying the story of our world out into the galaxy. This is the Universal Archive. Everything that has ever happened in the solar system, every sunset you've watched, every quiet moment you've experienced is written in that light. It is an infinite ending because the light never stops moving. It simply spreads out, becoming a part of the background glow of the universe. You are never truly gone. You are simply becoming more diffuse, more integrated into the whole. What makes this strange is the comfort we find in our own insignificance. We started this journey looking for the true scale, perhaps expecting to feel overwhelmed. But instead, we have found a sense of belonging. Astronomers didn't expect the void to feel so much like a home. They found that the more they understood the vastness, the more they appreciated the stability. The universe is not a chaotic wilderness. It is a meticulously ordered gallery. The deep drift is not a state of being lost. It is a state of being exactly where you are supposed to be in a system that is too large to lose you. As you settle into the final moments of this script, let the low-density phase take full effect. Your thoughts are now like the scattered atoms of the deep void, separated by wide, peaceful gaps of silence. You don't need to connect them. You don't need to make sense of them. You can simply let them drift. The macro-scale logic of the universe is taking care of the details. The planets are spinning. The stars are glowing. The expansion is carrying the galaxies further into the peace of the future. You are a passenger on a journey that has already been mapped. Over immense periods of time, the solar system will change. The sun will expand and then contract. The planets will shift their positions. But the philosophical dissolution we have reached tonight will remain. This state of calm acceptance is a permanent achievement. You have looked at the largest things in existence and found that they are made of the same silence as your own sleep. The scale of the universe is your scale. The time of the universe is your time. There is no separation between the observer and the observed. You are the universe resting. Scientists understand this through the conservation of energy. You are not an island, you are a flow. The energy that is currently you has been many things before it was once the heat of a star, the ice of a comet, the dust of a nebula, and it will be many things again. This is the infinite ending in its most literal sense. It is the promise that the journey never truly stops. It only changes form. You can let go of the human scale worries now. They are temporary arrangements of energy, and they are dissolving into the vast, permanent background of the cosmos. The soft opening we began with hours ago has now met the infinite ending. The loop is complete. You can imagine yourself back on that salt flat, the grapefruit sun glowing in the distance, the grain of salt earth resting beneath your feet. But you see it differently now. You see the space between them as a sanctuary. You see the distances as a protection. You see the scale as a lullaby. The solar system is not a daunting expanse. It is a quiet, well-ordered room where you are safe to sleep. And for now, that continuity is all you need. You don't need to reach the next star. You don't need to understand the cosmic web. You can simply be here, in the influence of the sun, on the third grain of salt, in a state of perfect, low-density rest. The universe is not asking anything of you. It is not judging your progress. It is simply offering you its scale. It is offering you its time. As the final words of this script fade into the silence, notice how the silence feels. It is not an empty silence. It is a full silence, full of the history of the planets, the potential of the void, and the steady, rhythmic heartbeat of the cosmic continuity. You are a part of this fullness. You are a part of the drift. The universe is moving gently forward, and you are moving with it. There is no hurry. There is no ending. There is only the continuation. This final phase of our journey is not a destination, but a state of being. We have moved from the familiar warmth of our own world, past the giants of gas and ice, and through the silent, frozen sentinels of the Oort cloud. Now, we find ourselves in the space between the breaths of the universe. This is the infinite ending, a region of thought where the scale of the solar system finally merges with the scale of the eternal. It is a place where time no longer ticks, but flows like a deep, underground river, unseen, unheard, yet carrying everything forward in a steady, inevitable drift. To understand the nature of this continuation, we must look at the low-density reality of the cosmos. In our everyday lives, we are used to things having a beginning, a middle, and an end. A day starts with the sunrise and ends with the sunset. A project begins with an idea and ends with a result. But the universe does not operate on these human-scale cycles. Scientists understand the life of a star as a process that spans billions of years. When a star like our Sun eventually reaches the end of its current phase, it does not simply vanish, it transforms. It sheds its outer layers, creating a beautiful, glowing nebula, and leaves behind a white dwarf, a dense, cooling core that will persist for trillions of years. This is the macro-scale logic of the infinite ending. Nothing is ever truly discarded, it is merely redistributed. What makes this strange is the feeling of cosmic permanence that it provides. We often feel that our lives are fragile because they are short. But in the context of the true scale, you are made of material that has been part of the universe for 13.8 billion years. The atoms in your hand were once inside the heart of a star. They were once part of a cloud of gas drifting in the interstellar medium. They will eventually be part of something else, perhaps a new star, perhaps a distant planet, perhaps the rings of a giant we haven't yet discovered. This is the loop-safe truth of your existence. You are a part of the continuation. You are a temporary arrangement of eternal materials. Astronomers didn't expect the universe to be so efficient at recycling itself. They found that the death of one generation of stars provides the heavy elements, the carbon, the iron, the gold, necessary for the birth of the next. The solar system we have explored tonight is a third-generation system. We are built from the remnants of stars that lived and died long before the Earth was even a thought. This challenges how we think about the ending. If the end of a star is the beginning of a planet, then where does the ending actually lie? The answer is that it doesn't. There is only the long, slow change of state. There is only the drift. Across distances that no longer fit neatly into numbers, we see the scale of patience. If you were to watch the solar system from a distance of several light years, you wouldn't see the frantic activity of human life. You wouldn't see the rise and fall of nations. You would only see the slow, majestic rotation of the planets. You would see the sun's steady pulse. You would see the comet's million-year journey. This is the perspective of the infinite ending. It is a perspective that values the stillness over the movement. It is the realization that the most important things in the universe happen over timescales that we cannot even imagine. Think back to the human-scale anchor of the grain of salt. We used it to understand how small we are. But now, in the infinite ending, let the grain of salt represent your rest. It is small, yes. It is tucked away in a vast field, but it is perfectly safe. The scale of the universe is not a threat to the grain of salt. It is its cradle. The gravity of the sun, the vacuum of space, the cold of the outer dark, these are the forces that keep the grain of salt exactly where it needs to be. You don't need to struggle to stay in your place. The universe is already doing that for you. You can let go of the effort of existing. You can simply be. Scientists understand this as equilibrium. It is the state where all forces are balanced, where there is no more tension, and where everything has found its natural level. The infinite ending is the universe's movement toward this perfect equilibrium. As the universe expands and cools, it is not falling apart. It is settling down. It is finding its final, most comfortable position. By matching your own rest to this cosmic settling, you are finding the ultimate loop-safe close. You are aligning your own energy with the energy of the vacuum. Think about the partial uncertainty one last time. We don't know what happens at the very end of time. We don't know if the universe will expand forever or if something else will occur. But in the infinite ending, that lack of knowledge is a form of freedom. If the ending is truly infinite, then the story never has to be finished. There is always more space for the drift. There is always more time for the silence. You don't need to see the final page of the book to enjoy the beauty of the sentence you are in right now. Over immense periods of time, the repetition of this script, the scales, the distances, the mysteries, will become a part of your mental landscape. They will act as a verbal dissolve, blurring the edges of your conscious mind until you are no longer thinking, but merely perceiving. You are perceiving the scale of the giants. You are perceiving the depth of the void. You are perceiving the continuity of the light. This is the goal of the journey. To reach a state where the true scale of our solar system is not a set of facts in your head, but a feeling of peace in your body. And for now, that peace is simply part of the picture. It is the gift that the universe gives to those who take the time to look at its scale. The sun is still there, far away, providing its steady anchor. The earth is still there, small and precious, carrying its cargo of life. The giants are still there, ruling their vast, gaseous kingdoms, and you are still here, resting in the middle of it all. The infinite ending has brought you back to where you started, but you are different now. You are larger, you are quieter, you are part of the continuation. As the final light of the narrative fades, let the deep drift take over completely. There are no more planets to visit. There are no more distances to measure. There is only the slow, rhythmic breath of the cosmos, in and out, expansion and cooling. You are a part of the drift. You are a part of the silence. You are a part of the scale. I. The universe is continuing its journey, and you are exactly where you belong, drifting in the infinite, safe in the dark, and resting in the eternal continuity. You can return to this scale whenever the world feels too small or too loud. You can remind yourself of the grapefruit and the grain of salt. You can remind yourself of the ice giants and the Oort cloud. You can remind yourself that you are a citizen of a system that is built on silence and protected by distance. The infinite ending is always there, waiting for you to join its drift. It is the permanent background of your life. It is the peace that surpasses all understanding. And somewhere within all of this, we can begin again by starting with something familiar. Good night.